Hello everyone. Today we are starting with one of the simplest sorting techniques, which is bubble sort. So let me create a file. Let's name it as sort. So the first question which might arise in your mind is, what is sorting? Like, what is it actually? So here I have an array. Let's say 5, 3, 4, 1 and 2. Either you have to sort it in ascending order or in descending order. What I mean by that is, either it should be in this order 1 2 3 4 5, or in this order 5 4 3 2 1. Okay, so in order to do this, there are several sorting techniques, and bubble sort is one of them. So let's take our example. This array 5 3 4 1 2, 5 3 4 1 2, and in bubble sort what happens is, like, there's an outer loop and inner loop. There's an outer loop and an inner loop. So in the inner loop we check, like, we start the pointer from array index 1. So we check, like, which element is at array index 1 here? 3. So we will check, is 3 less than 5? It will be like, yes it is. So swap, it will just swap it with 5. 3 5 4 1 and 2. This will be our array. In the next iteration, now my pointer is somewhere over here at 4. It will once again check, is 4 less than 5? It will like, yes it is. Swap 3 4 and 5, 1 and 2 as it is. So now my pointer is at 1. It will once again check, is my 1 less than 5? It will be like, yes it is. Again swap 3 4 1 5 and 2. We'll ask the same question. Swap 3 4 1 2 and 5. At this point, the whole first iteration of the inner loop will be complete, and the whole first iteration of the outer loop will be complete. Now moving on to the second iteration. Note one thing, that in every iteration, the greatest number is coming to the end. As you can see here, 5 is the greatest number in this array, and it's coming to the end of the array. Okay, so in the next iteration of the outer loop, it will once again ask, pointer will start from 4, as it is at first place of the array, first index I mean. So it will once again ask, is 4 less than 3? It will be like, no, it's not. Okay, move the pointer ahead. Now the pointer will be at 1. It will once again ask, is 1 less than 4? It will be like, yes it is. Swap 3 1 4 2 and 5. Now my pointer will be at 2. It will ask, is 2 less than 4? It will be like, yes it is. Swap 3 1 2 4 and 5. Now my pointer will be at 4. It will like, is 4 less than 4? It will like, no it's not, it's equal to 4. Okay, now at this point, the second iteration for the outer loop will be complete. And note here, the second largest element is like sorted in its place, and this will keep on happening for all these iterations, for all the other iterations that are remaining. So I hope you got the basic idea what we are going to do in binary sort, bubble sort. So let's code this. Here's my array. What's the starting array? 3 5 4 1 2 1 2. Let me create a function. This function will be of type void, as it will not return anything, it will just change this array. Sort. In parameters, I just want this array. The outer loop will start from 0. It will be less than array's length, and it will keep on incrementing. And for the inner loop, it will start from 1, as I have to check like is my array at like first index less than my array at like 0th index. So if I keep this pointer at 0, it will show array at index out of bounds, as there is no index before 0. I hope it's clear. J will also be less than array.length minus I. Now you may ask, why is J less than array.length minus I? See, in each iteration, in the first iteration of the outer loop, like the first largest element is coming to its place, like it's sorted. In the second iteration of the outer for loop, the second largest element is sorted, and here is sorted. So in every iteration, like in fourth iteration, suppose the fourth largest element will also be sorted. So isn't it ideal that we just keep our starting and end points to that extent that which is not sorted yet? It will just like increase the efficiency of our algorithm. Look what I mean by this. As you can see here, in the first iteration our array was something like this: 3, 5, 4, 1 and 2. In the second iteration it was something like this: 3, 1, 2, 4 and 5. In the third iteration it will be something like this: 1, 2, 3, 4 and 5. Okay, as you can see here that here, yes, these two elements are sorted. So why do I need to check once again, are they in the correct spot or not? Why do I need to check is like 5 less than 4? It's obviously not, as it's already sorted. So that's why what I'm doing is I'm just checking this half of the array, as these two elements are sorted already. I hope this clears any sort of confusion that may arise. Okay. So I'll say what I have to check. I have to check if my array at j, which will be like in the beginning at the first index, is less than array at j minus 1. Just swap it. Array at j is equal to array at j minus 1. Array at j minus 1 is equal to 10. Okay, we are just swapping array at first index with array at 0th index only if this condition checks up. That's pretty much it. One more thing, I'll say bool. Yes, it's boolean in Java. Yes, boolean swapped. It will be false in here, and 2 in here. Now I can see Swap is equal to false. Sorry. Swap is equal to false. Just break. Why am I using this boolean? You may ask why I'm using this. As you can see in the third iteration, our array might look something like this: 1, 2, 3, and 4 and 5. After the third iteration, it should look something like this. As you can see, it's already like sorted. So this this condition won't check up. Like array at j, it will be at starting first index. Is it less than j minus 1? It will be like, no, it's not. Index will go on here. It will once again ask, is array at j less than array at j minus 1? It will be like, no. So as you can see, no swap will take place. So in the outer loop, swap will be equal to false. If this condition checks up, swap will be equal to true. Okay, if any swap took place, it will be equal to true. So if no swap took place, we already know that this array is already sorted. So that's why I'm mentioning here, if swap is equal to false, just break this outer loop. I hope it's clear. Yeah, that's pretty much it. Let's print our array. Call this function first. To string. Let's see what happens. As you can see, our array is sorted. Let's put the debug pointer over here. Let's debug this. Wait a second. Let's debug. Swap is equal to false. It will check if array at first index is less than array at 0th index. It will like, no, it's not. So moving on to the second, it will check if array at second index is less than array at first index. Like yes, it is. So it will swap. Swap will be equal to true. So as here you can see, after the first iteration of the outer loop, our 5 came like right to the end of this array, as it is the greatest like largest integer in here. Same will happen in the second loop, third loop, so on. So that's pretty much it about bubble sort. In the next video I'll be talking about insertion sort.